Welcome back. Lesson 4. So we're starting a new module here, the module of descriptive statistics. So just to recap what we've done so far, in Lesson 2 we learned about the basic data types, populations and samples. In Lesson 3 we did some graphing. Now again, I didn't get to all the different types of graphing. We hinted at bar graphs, we did histograms. There are obviously other types of graphs, most notably pie charts, box and whisker plots. Pie charts aren't really crucial to this course, and I think you've seen a lot of them before. There's not much else I can really talk about. Besides, they're pretty tough to construct by hand anyway. So I focused on the histograms. There is one other graph of data called the box and whisker plot, which you will see later on. So we're going to kind of revisit the graphing part. But what I want to move on to right now is we're going to start calculations. This is where we're going to start with the formulas. And again, I mentioned in the opening video, I'm going to try to stay away from formulas as much as possible. I don't want this to be a formula-based course. However, I feel an obligation to at least show you the formulas and, where possible, kind of show you where they come from. I will do some derivations and proofs. Again, nothing real complicated. And it's the type of thing that, the type of thing that you can mostly ignore if you don't understand it. And I'm not going to rely too much on formulas, but some formulas you do need. I mean, so, we're going to do a lot of calculations based on using technology, but I think it's important to see at least where these come from, even if you don't use them very much. Otherwise, when you calculate your statistics, you're just putting numbers into a computer, and to me, it removes some of the meaning. It makes it harder to understand. So, that being said, we're going to talk about measures of center and measures of spread. So I put this all as one lesson. I might wind up splitting this into a 4A and 4B. We'll see how this goes, because there is a lot here. So measures of center. So these are the measures, these statistics that you're probably most familiar with. The big three, the 3 M's, mean, median, and mode. Those are what we call measures of center. The arithmetic mean is the first one, and generally we're going to refer to it as the mean. When you see the term average, that's generally what they're referring to. They're referring to the average. When you see the term average, that's generally what's being referred to as the mean. So let me explain the formulas we see here. Again, don't get freaked out. I'm going to explain all of these, and this is something you're probably familiar with, although you haven't seen it in this form. So let me just start with this symbol here. This is the Greek letter sigma, and it just means to add up. Find the total. So really all that's happening here is we're saying add up all data points. Remember, x is the random variable. So we're going to take all of the values of x, x1, x2, x3, however many data points they are, and we're just going to add them up. And these variables here, this capital N, refers to the size of the population. We're not going to deal with population size too much. A lot of the calculations that we'll be doing later in the course assume that the population is, for all intents and purposes, infinite. This is one we're going to see a lot more often. And really, all this means is we're going to add up all the numbers and divide by the number of numbers. And that's really all it is. So we'll just do a quick example here. Suppose you have a data set. Let's go back to let's say the cars data. Oh, no, the math scores data. And I'm just going to take a sample of 5 here. And so you'll notice, I hinted on this before, the difference between these two symbols. The process is the same. You add them up and divide by the number of numbers, whether that's the population or the sample. the distinction between these two symbols, between the population mean and the sample mean, will become important later on in the course. For now, they're mostly interchangeable, but I'm going to just approach everything like it's a sample, because that's really what we're going to. We're not going to do calculations based on the population. We're going to do calculations ultimately based on samples. So I'm going to treat this as a sample of test scores. In fact, probably are a sample from a larger class. So really all we're doing is just adding these numbers up. We normally wouldn't write all of these out. So we're going to say 100 plus 88, 84, 72, 58. That gives us a total of 402 divided by 5, because there are 5 data points, 1, 2, 3, 4, 5, and that's it. That's really all a mean is. Now, just a word on decimal places. I used one decimal place here. My rule of thumb, when it comes to number of decimal places, one more decimal place than the original data. So the original data has 0 decimal places. They're all whole numbers. So I'm going to use one more. So whatever that comes out to. So in this case, it's 1 decimal place. And that's really all there is to the mean. I want to move on to the median. The median is a value that lies in the middle of the data when arranged in ascending order. If there's an even number of data points, we take the average of the 2 middle values. So let's do a couple of examples. Let's start with the test data that we entered. So 58, 70. I got to put these in order. That's the 58, 72, 84. 88 and 100. So the median is the middle data point, which you can see here is the 84. You can count up 2 edges and you can kind of work your way toward the middle. And we'll do one more example here. Let's take maybe the cars data. So let's say you have a sample of 8 households. So let's say we have 8 households and they have 0, 1, 2, 2, 2, 3. Okay, now there is no middle. If we count up from the edges, we get 2 numbers. So this is probably not a good example, but basically we're going to take the average of the 2 middle points, an average of 2 and 2, which is just 2. So maybe we'll do one more example here. 1, 2, 2, 3, 4, 4, 6. So another sample. All right, so we can divide the data set in 4 and 4, and the median here is going to be 2.5, because it's halfway between 2 and 3. We're just taking the average of the 2 middle. Okay, so that's median. The last one we'll talk about is mode. We're not going to see this you're not going to be finding the mode too often. Generally, when we refer to mode, we're referring to the most frequently occurring value or values. This includes a range of values. You can have more than one mode, or you can have no modes. And the mode is the only measure that can be done with qualitative or non-numerical data, because you don't have to, it doesn't require any actual calculations. So if you have a data set like this, then the mode is going to be 1, because 1 occurs most often. If you have a data set like this, you have what we call bimodal data. 1 and 2 are kind of tied. If you have all the numbers, if there's a tie between a lot of numbers or no number occurs more than once, then there's no mode. And that's pretty much all I'm going to say about mode. Like I said, we're not going to use that too often. Mostly when we do refer to mode, if we refer to a histogram that we saw in the last lesson, the mode in a histogram is easily identifiable. It's simply the highest bar. It's the mode or modal class if you have more than one If that's the interval, 20 to 29, then 20 to 29 is the modal class, even though there might not be a mode in that data. Okay, I want one more idea here when it comes to finding means. Sometimes you'll need to find a weighted mean. And a weighted mean, when we found the means of the data so far, every data point counted equally. So you simply add them all up and divide by the number of numbers. But sometimes some numbers will have a higher weight than others. So here we have test scores ranging from 3 to 10, assume it's out of 10. But the 5 is going to count twice as much as the 4. I don't want to just add all these up and divide by 8, because some are counted more than others. So basically, what you would do if I'm going to find the mean to this data, the actual data set is, well, there's 2 3s, there's 2 4s, there are 4 5s, and so on. So listing all of these out just to find the mean can be a pain, and that's why we use this formula, which is, again, I'll go through how to find that. What we're going to do is we're going to take all of the frequencies and multiply them by the number itself, and then divide by the number of frequencies. And this is rather intuitive when you think about it. We have 2 3s, so we're going to we have a 3, and there are 2 of them, so 3 times 2. We have a 4, and we have 2 of those, 5, and a 4 of those. This is the same thing as writing all of these out and simply adding them up. So that's really all we're doing here. There's a single 6, there is a 7, and there's 3 of them. There are 0 8s, so we won't even bother there. There's a 9, and there's 2 of them. Only because multiplying a number by 0 gives you 0 anyway. Whoops, forgot the 10. And how many numbers are we going to have here? Well, if we add the frequencies up, 2, 4, 8, 9, 12, 14, 15. So there are 15 data points. So it's just like we wrote out all 15 of these numbers and then divided by 15. So it's really the exact same process as the formula we saw before. But doing it this way means we don't have to write out all the numbers. So if you had not 15, but let's say 150 data points, you don't want to write out all 150 just to find the mean. This is just kind of a shorthand way of doing it. So 3 times 2, 4 times 2, 5 times 4, 7 times 3. And again, I said there wouldn't be a whole lot of formulas in math here, but, at least initially, I want you to be able to find these by hand. Ultimately, by the time we get to the end of the course, you'll be given means from a sample data. We won't be finding them at all. They'll usually be numbers that are provided in the problem itself. So you're not going to be doing this by hand throughout the entire course. It's just when I first cover a topic, I think I'm doing a disservice if I just put everything into an app. Then like I said, it loses some meaning to it. 21 plus 18 plus 10, and that's 89 divided by 15, 5.93. I'll put 5.9. I'll put the squiggly equal sign, and just, so I'll sometimes do this. This means approximately equal. I can't say it's equal to 5.9 because it's not. I had to round off to 5.9. So technically, we should put approximately equal to 9. But that's going to be the mean. And if you wrote out 3, 3, 4, 4, 5, 5, 5, 5, and so on, and divided by 15, you'd get the exact same number. The most frequent use of weighted mean is when you calculate GPA. So if you have a course where, let's say you have, I'm going to put all the grades in terms of numbers, higher credit courses count more. So you have a grade of 3.8 in a 3-credit course, 2.5 in a 1-credit course, and let's say 3.1 in a 5-credit course. To find the GPA, this is how GPA is calculated. we're going to take that 3.8 is going to count 3 times. The 2.5 is going to count once. And the 3.1 is going to count 5 times. And the total number of credits is 16. So 3.8 times 3. 2.5. 3.1 times 5. 11.4. So this is just kind of a real life use of weighted means. There are certainly others. Divide that by 16. Oh, why am I saying 16? It's 9. What are we getting? Unusually low number. So 3.267. The only reason I'm using 3 decimal places is because that's typically how GPAs are expressed. So that's the only reason. Normally, I would just say 2 decimal places because it's one more than the original data. So I think I'm going to break the lesson off at this point. I'm going to break this into 2 smaller videos. So we're going to finish lesson 4 in the next video, and we're done talking about measures of center, but just as important is how varied is your data. Very important topic, and we're going to talk about that in the next video. So I'll see you then. Thanks for watching.